Hi, my name is Demeter, and in this video I would like to give you an introduction on weight painting, also called skinning in other software. The most common use for weight painting is to make characters deform during animation, and that is probably why you clicked on this video. Some people also use the terms weight painting and rigging interchangeably, but to me rigging means creating bones, constraints, and drivers to make a control rig, which is not the focus of this video. Weight painting usually happens after you already have a control rig, but technically nothing is stopping you from doing it the other way around. So what is weight painting? Weight painting is the authoring of vertex groups in a fast and intuitive way. So before we go any further than that, let's have a crash course on vertex groups. Delete everything beside the default cube. Then select the cube, go on the data panel in the properties editor, and I can add a new vertex group with this plus button, and I can double click on it to change the name. Every mesh object in Blender can have any number of vertex groups, but as you can see, their names have to be unique, so two vertex groups on the same object cannot have the same name. If I switch to edit mode, the UI changes a bit, and now allows me to assign or remove weight values. If you open the end panel and go to item, well, you'll see nothing relevant because we haven't assigned any vertices to any groups yet. So I'm going to select my hello group and click assign. Still, what I want to show you is not here because we need to have an active vertex, so I'm just going to select a vertex. And now you can see there is a vertex weights panel, and this shows the weights assigned to the active vertex. So as you can see, the hello vertex group has a weight of 1.0. Because of the terminology, you might think of vertex group assignments as binary. Either a vertex is in a group or it isn't, but that's not the case. Each vertex group can associate a value between 0 and 1 with any number of vertices on the mesh. For example, if I were to select every vertex again and set this weight value to 0.6 and then hit assign, all of those vertices would have a weight of 0.6. And this will of course have a significance once we start using vertex groups to deform our mesh. So let's go ahead and do that. Let's go back into object mode and add an armature with a single bone. I will go in viewport display in front so you can see it through everything else. And so in order to deform a mesh using an armature, you need to add an armature modifier and then select the armature. Now you'll notice of course that if you just select the armature and move it, that's not going to move the cube. And in fact, even if you go into pose mode and move the bone, that's still not going to move the cube. Unfortunately, the armature modifier can't read our mind, so we need to make sure that there is a clear association between the vertex groups and the bones. This is done by ensuring that the bone name and the vertex group name are an exact match. So this default bone is of course just called bone with a capital B. Let's go and rename our vertex group accordingly to bone. And now, if we move the bone in pose mode, it will move our cube. Note though that if you move the armature in object mode, it's still not going to move the cube. If you want to do that, you would have to parent the cube to the armature using Ctrl P. Although doing this is not necessary, it is standard, and you can even do these two things in one step, that is, parenting the cube to the armature and adding the armature modifier. You can also undo that in one step, so if I select the cube and I hit Alt P to clear parent, notice that it automatically removes the armature modifier for me. So now if I go and with the cube selected, shift select the armature and press Ctrl P again, but this time I choose armature deform, it's going to parent the cube to the armature object as well as add this modifier for me. Now you might have noticed something unexpected when I was moving this bone in pose mode, which is that even though we assigned a weight of 0.6, this cube seems to be following completely, even though you probably expected it to be following only 60% of this bone's transformations. This is because the armature modifier normalizes vertex weights that are used for the deformation before applying said deformation. To help me explain what I mean by normalization, let's do a couple of things. First, let's add another bone to this armature. I will duplicate this one, and I'll call this other. Then let's create a vertex group for it and assign a value of 1 for all vertices, as well as assign a value of 1 for the original vertex group. So now, just to double check in this panel, for all vertices, both groups are assigned 1.0. Now if we go back and try to move these bones in pose mode, you see that each bone appears to be moving the cube by about half of its transformation. So if I were to move this bone by 6 units on the x-axis, it looks like the cube has moved 3 units. Now you might be catching on to what's going on here. Even though the weights of each bone is 1.0, the armature modifier sees their normalized values. That is, as if each weight on each vertex was divided by the sum of all weights on that vertex. So in this case, 1 plus 1 is 2. That's the sum of all weights on a given vertex. So for both vertex groups, 1 gets divided by 2 and you're left with 0.5, meaning each bone will deform the cube by half of its movement. Now if you think back to what happened earlier, when we had a vertex weight of 0.6 and nothing else, the sum of all weights was 0.6, so 0.6 was divided by 0.6, giving us 1. And that's why the cube followed the bone completely, instead of only 60% of the way. I hope this is at least starting to make sense, because I think it is rather important. Of course, if you do a lot of maths in your daily life, you might be rolling your eyes by this point, because this is very obvious to you. But it's understandable to be confused because there is a disconnect between the numbers that you see here in the end panel versus the deformation that you see when you move the bones. Also, when you enter weight paint mode, it commonly causes confusion that even though bone's influence is red, which represents the maximum, the mesh is still not necessarily moving one-to-one with the bone, which is the case here. The good news is that there are ways to avoid this confusion. For starters, there is a normalize all operator, which lets you normalize your vertex groups. Make sure you don't mistake this for the normalize operator, which has a much more niche purpose. So let's see what happens if you do normalize all. Well, that's probably not what you expected, because one of the weights just turned into 1 and the other turned into 0. This is because of a rather unfortunate default parameter of this operator. If you go in the operator settings, you'll see that lock active is enabled by default, which completely defeats our purpose, so untick that. And now we get the result that we expected. The two weights are now 0.5 and 0.5, which matches the deformation that you see when you move the bones in pose mode. The other important feature that lets us deal with this is auto-normalize, which will normalize your weights every time you make a stroke while in weight paint mode. But let's not get ahead of ourselves. First off, how do we even enter weight paint mode? You can, of course, simply enter weight paint mode from the object mode drop-down menu like I just did, but when working with an armature you probably want to be able to select the bones, which would allow you to quickly switch between the relevant vertex groups. But as you can see, that's not working right now. In fact, I can't even so much as select the armature object. There's two ways around this. One is to go into Edit, Lock Object Modes and disable this option, which will allow me to select the armature object, then I can go into pose mode and go back to my cube. Alternatively, if you don't want to do that, the way you want to enter weight paint mode is that you first select the armature, then you shift select the cube, and then you enter weight paint mode. And now you can select individual bones, which will also activate their corresponding vertex groups, as you can see here. Although these two vertex groups happen to be identical at the moment, but before we start weight painting I would like to apply a subdivision modifier on this cube so we have some more vertices to play with. So I'm going to go back to object mode, press Ctrl 2 on the cube, and then hit apply on this subdivision modifier. Also note that selecting bones will only work if this armature modifier is present. If you remove it, you won't be able to select bones no matter what you do. So let's undo that. At this point you can forget about a lot of the UI that I've shown you so far. You will no longer need to worry about the vertex weights panel, nor the vertex group list, or adding vertex groups manually. And to show you why you don't need to worry about it, let's delete all the vertex groups, and then go back to weight paint mode. Now just select a bone of your choice, and left click anywhere on the mesh. As you can see, the vertices inside the brush circle have all snapped over to this bone, called bone, and its vertex group got automatically created. And if I try moving this bone, all those vertices are going to move with it. And if I reset that bone to its original position, then our sphere looks like a sphere again. And this is what I meant in the very beginning of the video, when I said weight painting is the authoring of vertex groups in a fast and intuitive way. Painting with brush strokes is a lot faster and more intuitive compared to assigning weights manually, vertex by vertex. As you can probably tell, the values of weights are represented by colors, where blue means 0, red means 1, and there's shades of aqua, green and yellow in between. You can customize these colors under Edit, Preferences, Editing, Weight Paint, use custom colors. But I recommend you only do that if you are colorblind and, for example, have a hard time seeing the difference between the yellow of a 0.8 versus the red of a 1.0, because then you're going to have a bad time. But actually it turns out Blender itself is quite colorblind. What I mean by that is, by default there is no distinction between an assigned weight of 0 versus no assigned weight at all, which I think is a bad thing, and I will explain why when I talk about auto-normalize. But to fix this, go in the overlay settings and set the 0 weights option to active. This way, weights with the value of 0 will still be blue, but when a vertex is not assigned to a group at all, it will be black. There is no downside to turning this option on, so please do. It can save you a lot of headache. Alright, I think this is a good time to end the first video. If a lot of the information here was new to you, please take some time to play around with what you've learned so far and digest. Although weight painting will never be the most thrilling thing you can learn in Blender, this was definitely the boring theory part. In the next video we will start weight painting an actual character, looking at the brushes, settings and more. See you then!